Features of long-run expansion joint. The long-run expansion joint has been developed to solve the problems that conventional expansion joints are incurring: expensive repair costs and fatal traffic accidents because of bolt breakage and bolt releasing due to excessive stress to support bolts. Long-run expansion joint distributes the stress of bolt to cogged joint and reduces bolt releasing and bolt breakage. The fatigue test shows 16.4% declines comparing with existing methods for the loss rate of loosening torque. Also, it is applicable to skew bridges thanks to its extrusion method that can allow to produce in accordance of finger angles and sizes. FEM structural analysis shows concentrated load on the bolt part equally distributes to cogged joint. So, it proves preventing bolt loosening. We also use a special washer to prevent bolt loosening. Long-run expansion joint allows transverse movement as well as longitudinal movement, so it prevents damages due to finger interference and allows transverse behavior during earthquake. It is also able to replace only a rubber seal without breaking post-placing concrete, so it reduces maintenance cost and repair time. Also, it prevents secondary damages due to water leakage by installing a rubber seal as much as bridge width. And prevents fatigue increase on the end of slab and girder. It is also an eco-friendly method because it reduces construction wastes. Moreover, it is more economical as you can replace only a top plate in case of breakage. Unlikely rail-type expansion joint. Finger-type structures greatly improved driving comfortability and reduced noise thanks to its continuous structure. Introduction of long-run expansion joints. LFJ is a transverse expansion joint and it is suitable for large movement and requiring less noise. LCFJ is to replace existing rail-type expansion joint to finger-type by installing an independent bracket using the existing anchor. BFJ is a transverse expansion joint and suitable for long-span bridges. LCRJ is able to use both longitudinal and transverse and suitable for small movement, and it is economical. LRJ is able to use both longitudinal and transverse and suitable for small movement. LMJ is a transverse expansion joint and suitable for small movement. It offers great driving comfortability with less noise. LCJ is able to use both longitudinal and transverse. Due to its excellent waterproofing, it is suitable for culvert expansion joint as well. LHAJ is to secure vehicles' drivability by adjusting slab's height difference. When there is height difference between slabs, vehicle approaches to the adjacent slab as much as half-wheel inclination than general types, so it is much safer and also prevents damages on the sides of tires. ERJ is an earthquake-resistant expansion joint which allows X, Y, and Z movement. It can be applied to cable-stayed bridge, suspension bridge, and curved bridge. RWJ is a railway expansion joint, and it has excellent waterproof due to its integral structure. LAWJ is an agricultural waterway joint, and it is easy to install because rubber seal is a bendable structure depending on the angle grade of hunch inclination. LEDPS is a double-layer seal and has an excellent performance for debris prevention. During expansion, top rubber expands and prevents sag. And during shrinkage, bottom rubber pushes the top rubber, and that pushes the debris. Installation procedures of long-run expansion joints. The installation procedures of LFJ is firstly, proceed concrete blockout and then install rebars and mount expansion joints horizontally, and then place the concrete. And then release the bolt. Disassemble top plate and then place rubber seal and punch the holes for the bolts. And then assemble the top plate and tighten the bolts. And finally, finish with applying sealant around the bolt holes. The installation procedures of LCFJ is firstly, proceed concrete blockout and then remove the existing rail-type expansion joint and then weld independent bracket to mount LCFJ. And then weld bottom plate of LCFJ. And then place rubber seal and punch the holes for bolts. And then assemble the top plate and tighten the bolts. And finally, finish with applying post-placing concrete.